In this video, I'm going to go through electronic homework module 8, number 2. So we have 3x to the 6th, y to the 4th, plus 15x to the 5th, y to the 5th, plus 3x to the 4th, y cubed. So first we want to find a greatest common factor for all of those. What goes into each term. So if you take each separate piece, just look at the number parts first. So here I have an arrow in red going to the number part. And we can see, if we scroll up here, you can look, and the GCF, the greatest common factor of 3, 15, and 3, what divides into those without a remainder would be 3. So I'm going to write that just right over here. Then I'm going to track the next factor here. I'm going to look at the x expressions there. X to the 6th, x to the 5th, x to the 4th. So I just can write those down there. Pick the one with the lowest exponent. That will divide into x to the 5th and x to the 6th. That's what we're looking for. What do they share? Well, they all share x to the 4th. Then the third one are the y's. So you can see down here, y to the 4th, y to the 5th, y cubed. So pick the one with the lowest exponent. So out of all of those, if we put that together, our greatest common factor would be 3. I'm just going to write it up here, just right down here. GCF of all of them, all terms together, would be 3x to the 4th, y cubed. So that's the first part. Got that. Now we have to multiply that by what would be remaining if I were to factor that out. So in essence, I have to divide that. So I'm going to rewrite that and show you how to list that out so you can keep track of it easier. Okay, so I just rewrote the original problem here, 3x to the 6th, y to the 4th, plus 15x to the 5th, y to the 5th, plus 3x to the 4th, y cubed. And I take that greatest common factor from all these terms and put it on the left here. Then I'm going to want to just give myself some parentheses. I have to divide that greatest common factor into all 3 of these terms and then write it down here, what's left over. So if I divide 3x to the 6th, y to the 4th, by 3x to the 4th, y cubed, then I just look at it as if it's just one monomial here. Okay, and then I use my skills of my exponent properties. So 3 over 3 would leave me with just a coefficient of 1. I don't really need to write the 1. X to the 6th over x to the 4th leaves me with x squared. I subtract my exponents. Y to the 4th over y cubed leaves me with y. And you can check back just by multiplying 3 times x squared to the y would give me this 3x to the 6th, y to the 4th. So that's how you can check it. Then I do the same thing here, divide by that same greatest common factor. And then what's left, so I can reduce here. And I get 5, the x, because I have 5 minus 4 for my exponents would just leave me with x. The y's I look at now, 5 minus 3, it would be y squared. And then the last one, I'm going to do same thing, divide by that same greatest common factor that I pulled out, and I would get x Nope, actually, I'm going to have x to the 0, right? So if I have x to the 0, that would be 1. Anything over itself is 1. Y cubes are 1, so I'm going to have a plus 1 on the end there. And then I look, I can't combine any like terms because I don't have any exact same variable parts. And that is my answer for this one. All the question was doing was asking how that would look if I factored out the greatest common factor from the polynomial. And so I would have 3x to the 4th y cubed times quantity x squared y plus 5xy squared plus 1. And that is not factorable anymore. And it does tell you just to pull out the greatest common factor. Sometimes we're left with a trinomial that we can factor, but a lot of times if it just asks you to pull the greatest common factor out, then you're done with that one. Hope that helped.